Okay, so let's take the look at another arc length. This time we've got a curve in terms of the function of x as a function of y. And we want to find the arc length of the curve on the interval from 0 to pi over 3. Okay, so in terms of our arc length formula, we know this. The arc length on the interval of y from c to d of the square root of 1 plus the derivative of y dy, that'll give us our length. And so we're going on an interval from 0 to pi over 3. This time we're going along the y-axis, right? So we've got 0 up to pi over 3, which is pretty close to here, right? And if we were looking at the value that we would get, it'd probably be something like this. Okay, so what is the length of that bit of curve right here? Well, of course, we're going to have to take a derivative. So let's see. We've got x as a function of y. So we need dx dy. So dx is going to be the derivative. Let's see, it's 1 over the cosine of y due to our natural log times the derivative of cosine of y, which is negative sine of y. Right? Dy, and of course just rewriting that so we get gy prime, which is x prime in here. Actually what we're going to get is the negative of the tangent of y, right? Why? Because, well, we've got the sine over the cosine. Alright, so now we've got this function that we're going to substitute in, right? This is our g prime. And so our length formula is going to look like this. We're going to take an integral along the y-axis from 0 to pi over 3 of the function square root 1 plus the square of our negative tangent of y dy. Well, you may not recognize it right away, at least the way that it's written, but just a little bit of a simplification shows us the following. That our function under the radical is 1 plus the square of tangent of y, and by our Pythagorean identity, that's actually an integral from 0 to pi over 3 of the square root of the square of secant of y dy. And so in fact we're going to be taking this integral from 0 to pi over 3 of the function secant of y dy. So now we think back, what will that integral be? Well, this is the integral that turns out to be a natural logarithm of the sum of secant of y and tangent of y on that interval from 0 to pi over 3. So let's see what that's going to look like when we substitute in our numbers. We want to take a natural logarithm of the quantity that we get when we take the secant of pi over 3 plus the tangent of pi over 3. And from that, we're going to subtract the natural log that we get by taking the secant of 0 and adding the tangent of 0. Alright, so we think back for a moment into our trig world, and we would recognize that we're actually taking the natural log of the secant of pi over 3, which is 2, plus the tangent of pi over 3, which is square root of 3, minus our natural logarithm of the secant of 0, which is 1, plus the tangent of 0, which is 0. Well, if you recognize that natural logarithm of 1, that goes to 0, and so we're left with this curve that has a length of natural log of 2 plus the square root of 3.